HOUDINI is our neurosymbolic system for doing deep lifelong learning. Currently, supervised learning systems are very focused on only one task. However, natural learning systems are going to see a large number of learning tasks over their lifetime. Ideally, we want them to learn much faster on later tasks by reusing information from earlier tasks. Suppose we have a learning system that has learned how to recognize and count the number of 5s in a list of images of digits. Then what we'd like to do is to transfer and learn other tasks faster. For example, given a list of images of toys, we'd like to count how many animals are in that list. When the system is learning about this, it should be able to reuse what it's already learned about counting, even if it's never seen a toy before. This is different than the way we currently do transfer learning in deep models, which is to reuse lower layers of the network. This is what we call low-level transfer. However, to do this kind of counting, you really need to reuse higher levels of the network, what we call high-level transfer. Lastly, we also want to avoid catastrophic forgetting of the knowledge obtained on previous tasks. It is possible to represent the deep architectures solving these tasks as a composition of functions. The main insight in our work is that to perform high-level transfer, a deep model can be rewritten as a functional program that reuses sections of a neural network from previous tasks. We call these sections functions, and given a new task, we search for a program that reuses some things from the library and creates some new things from the network. This search procedure is a type of program synthesis. HOUDINI is a neurosymbolic method in which a neural architecture is given by a symbolic program and its parameters are tuned by gradient descent. Our method maintains a library of functions trained on previous tasks. Given a new task, he searches through a set of functional programs using symbolic search that tries to choose which of the previous library functions to reuse. Also, whether or not to insert new trainable parameters, and what's the architecture that combines these components. Reusing different functions allows for low-level and high-level transfer. We next show how HOUDINI learns to count the number of animals in a list of toy images. HOUDINI has a library of pre-trained networks from the previous tasks. Given a new task, we use symbolic program synthesizer to search through possible programs, specifying the neural architecture and what to reuse. Next, we evaluate generated programs, tuning any new parameters. The best performing program for task 3 is the one reusing the counter from task 2, therefore HOUDINI returns this program. Since the best program introduces 2 new functions, we add these functions to the library and make them available for later. We evaluate our method on sequences of synthetic tasks, where we outperform the baselines. This concludes the presentation of our method. For more information, please check out our paper.